that line, oh, sorry. Okay, so here's our point and here's our line. We want a plane that contains both of those. So the equation of a plane, we need a direction, and the direction is told to us by the normal vector to the plane. So, I need to figure out a way to get a vector that is perpendicular to a plane that contains both of those. Well, you don't cross points, you cross vectors, but I think you're on the right track.
Yeah, can you cross the first vector 6, 0, 0, 2, 43, 7?
Well, the vector 6, 0, negative 2 is this vector, which may or may not actually be in our plane. I mean,
Why don't we just pick
because
two
you don't, your plane doesn't necessarily have to contain the origin. Like, I mean, we have a plane, it's not necessarily contain the origin. But I mean, you're on the right track, Chris.
Why don't we just pick two arbitrary points on the line and draw vectors to those points from our given
Yes.
point?
Yes, that's what we want to do. So, Chris, you're on the right track, that we want to find vectors, we want to cross them. A way to find vectors that we know would contain the point and contain the line, and thus, you know, be the plane we're talking about, is to make a vector that goes from our point to the line, and then make another one that goes from the point to the line. And then we'll have two vectors that we know have to be in our plane. So, we need 2 points that are on our line. So, and let me click back to the problem. So, some points that are on the line, okay, points that are on the line. Well, first of all, we know 4, 3, 7 is on the line. Because that's kind of the starting point, and then we get other points by using various values of t. And then let t equal 1, and if t equals 1, then the point 2, 8, 11 is also on the line. I put 1 in for t, and so 4 minus 2 is where I got the 2, 3 plus 5 is where I got the 8, and 7 plus 4 is where I got the 11. So then the vectors from our point 6, 0, negative 2 to these points, one vector is going to be, so I'm going from my point to these other 2 points. So 6 to 4 is negative 2. 0 to 3 is positive 3. Negative 2 to 7 is positive 9. And then 6 to 2 is negative 4. 0 to 8 is positive 8. Negative 2 to 11 is positive 13. So there are 2 vectors that I know are in the plane, and if we cross them, we will get a vector we know is perpendicular to them and to the plane. Those cross products are perpendicular to both vectors you're crossing, and since those are in the plane, they have to be perpendicular to the plane. So I will get 39 minus 72, and then we will get negative 26 plus 36, and then negative 16 plus 12.
Which one's T1? What's that one? T2.
So let's see, 39 minus 72 is negative 31, right?
Gotcha.
No, 33, wait.
Yeah, 30. We should just put 4 and 3 in this line. Oh, 0?
positive 10, but then that makes it negative, so negative 10j, and then this is negative 4. Okay, so that's my normal vector. And once you have the normal vector, then you pick a point that is in the plane. Why don't we just use, I mean, technically I could use the 2 points on the line, or I could use, I suspect if you were looking in the solutions manual, they're just gonna have you use the point they gave you. Okay, so then step 2 is pick a point on the plane, and negative 33x minus 6 minus